In this video I will again talk about the evolution of human diets, how we came from fatty meat as the base of our diet to poop to protect the environment. So I hope you watched the short video, which is a summary of my presentation, and I will go to the presentation itself. So please download the presentation as PDF file from the link in the description. Then you will get access to the sources of information, and you will probably understand better what is happening. We are witnessing a growing awareness about the importance of the environment and ecosystem protection, which is supported by governments, international organizations, and medical professionals. The following steps are proposed: reusing items whenever possible, recycling materials such as paper, plastic, glass, and metal, reducing energy consumption in households and industrial facilities by walking, biking, car sharing, and using public transportation instead of personal cars. Switching to renewable energy sources and using electric or hybrid cars to reduce greenhouse emissions. The preservation of natural habitats such as forests, wetlands, and coral reefs. And an important part of this agenda, which is important for us especially, is reducing meat consumption, eating plant-based alternatives, and promoting alternatives like laboratory-grown meat to lessen the environmental impact of the livestock farming. So it is not my proposals, but I know that at school kids are getting this teaching, so that we have to eat less meat and we have to use solar energy, etc. So it is, again, it seems to me crazy. But okay, well, whatever, this what we have. That again, that cows, which are actually the providers, provide the healthiest food for us, they are considered as the cause of the climate change. So farting of the cows, methane, it's like corresponds to rainforest destruction, at carbon emission, etc. It's absolutely crazy what is happening now. But whatever, let's go. Classic meat substitutes for vegans and vegetarians include soy-based products, wheat gluten, which is called wheat meat, burgers made from lentils and chickpeas and mushrooms. Numerous brands are offering vegan meat replacements made entirely from plants that closely mimic the texture of traditional meat products. Some of the prominent ones include this list of the brand names, and there are many other options available on market. Also, insect-based meat replacement are gaining attention as alternatives to traditional animal protein sources. These products are made of insect protein, mainly mealworms and crickets. Some examples include cricket flour, bread, pasta, meatworms, insect-based chips, protein bars, and burgers. So, okay, this we see the brands which are available on market. This is a plant-based meat replacement, meat substitute. So, okay, we are witnessing a large investment in the research and production of lab-grown meat, also known as cultured or cell-based meat, as an alternative to traditional animal culture. Over $2.6 billion American dollars has been invested in the cell-based meat since 2016, and 2021 cultured meat startups raised a record $1.4 billion in funding, and governments globally have invested $1 billion American dollars in developing cellular and plant-based meats. Researchers like Choji Takeshu are advancing in lab-grown meat production. Examples of cultivated ground meat products include beef meatballs, chicken nuggets, shrimp dumplings, fish cakes, lobster terrine, and lobster gazpacho. Okay, I never tried that. Okay, but okay, whatever. Some cultivated meat technologies use genetic engineering, others use embryonic stem cells and tumor cells. Again, in these reactors, in the production of this cell-based meat, what they use cells which are multiplying indefinitely. This can be only embryonic stem cells or tumor cells, which is most preferable source of such any. So if you buy and eat this cell-based meat, it is you consume tumor cells. Okay, the cost of production cultivated meat is high, and it is not yet clear if it can compete in future with traditional meat production. Okay, if again this guy is growing this meat from cancer cells, and okay, he expected that we will eat this meat. This is not meat at all. It's cancer, the tumor tissue. A large disadvantage of the cultivated meat technology is that hormones and growth factors are used to stimulate cells to multiply in the bioreactors. These substances may get into our body, certainly they will get, and ignite cancer development. Also, large quantities of antibiotics have to be used in cultivated cell structures. It may result in mutations and appearance of pathogens that are resistant to antibiotics. So the harmful environmental impact of cultivated meat production can be a magnitude higher, or maybe 2 orders of magnitude higher than of the traditional meat animal breeding. But of course, we don't want animal cruelty. Yeah, sure. I love dogs. I love nature, and but the production of eggs, for example, in dairy products, does not include the killing of animals. And compare how animals are killed in wild nature. They are killed and eaten alive. We never do it. Humans never do it. Meanwhile, growing monocrops and GMO crops such as soybeans is actually related to the destruction of the environment and killing billions of bees, worms, mice, birds, and other living beings. You know, it's again 10 years I'm in Thailand, and I see how less, fewer we have insects. For example, the termites, which are very important for our environment, for sustainability of the environment. And now this number of termites is dropped dramatically, maybe 2 orders of magnitude. Okay? So it is like here, happy cow. So they are getting embryonic stem cells from cow, from embryons, of course. So they kill embryon, they get these embryonic stem cells, and all this muscle cell. It is not muscle cell, it is tumor cells. So they get they produce from tumor some stem cells and get to the reactor. In the reactor, they supply oxygen and some nutrients and expect that it will grow. Eventually, they make not muscle fiber. It is impossible. They produce some kind of porridge from cells, and then but they can structure it with fibers from plant-based fibers and produce this fake meat. Okay, let's go. So of course production is very expensive now, but as food prices are coming up and people cannot afford to buy meat, beef is very expensive, for example, then okay, then probably this fake meat will be compatible in prices. The digestive system of humans is very different from that of herbivores and large primates. In humans, the colon comprises only about 20% of total volume of the digestive tract, while in large primates like apes, it constitutes about 50% of volume. Large primates, due to their sizable colons, can ferment fiber-rich food. Humans cannot. Meanwhile, the gastrointestinal tract of humans, with its expanded small intestine and reduced colon, is consistent with the consumption of a diet with large amounts of animal-based and cooked food. While humans are considered to be omnivores, our digestive system also differs from that of omnivores such as pigs, bears, dogs, and raccoons. Actually, the human digestive system shares many similarities with that of carnivores. Although our stomachs are smaller and we are not adapted to use proteins as the main source of energy. We cannot. So, and humans can be named lipivores because of their adaptation to high-fat, meat-centered diet. So, all our digestive tract is adapted not to plant-based food, but to animal fat, and of course some proteins. We need some proteins, but animal fat is a source of energy, supposed to be energy. And you know that newborn babies are in ketosis. They use fat as source of energy, by the way. So it is natural that we have to stay in ketosis and produce energy from fat. Comparison of the digestive system. Autonomy is represented here. As you can see, human digestive tract is much different from big apes, and also it is relatively close to dogs, but even then it is not. It is a little bit simpler because size of the stomach is smaller, and dogs can keep meat and can keep some proteins long in the stomach, but humans cannot. It's again our system is adapted to use fat. Fat is digested in the small intestine. Yeah, this is how it works. Okay, the pH of gastric juice in humans typically ranges between 1 and 2, which is close to the acidity of gastric juice in hyenas and vultures. High acidity helps disinfect foods such as rotten meat. Compared to other primates and mammals of our size, humans have very large brains. Additionally, the energy demands of the brain and other neural tissues are extremely high, approximately 16 times of those of skeletal muscle. It is accepted by science that the consumption of high-energy animal fats, such as bone marrow, was crucial for the evolutionary development of large brains in humans. Compared to large-bodied apes, humans have an enhanced capacity to digest and metabolize high-fat digest. Okay, this is how we develop. So compare human digestive system and digestive system of large apes, much different. We cannot stay on plant-based food. Even cooked plant-based food is not, we cannot get enough nutrients from this food. Moreover, humans have higher levels of body fat than other primate stories. Okay, we are actually like hyenas. We can eat rotten meat and get energy from rotten meat, but we also need more fat. Hyenas can survive on lean meat, humans cannot. The invention of cooking with fire led to increased brain size due to better nutrition. Brain size peaked in Europe 10-20,000 years ago, just before the invention of farming, then gradually decreased. Human brain reduction to its current volume, 1.3 and 1.4 liters, in the last 3,000 years was probably a result of a shift to an agricultural diet and the use of carbohydrates, especially grains, as the main source of energy. Since our civilization is based on growing grains, the average brain size and intelligence quotient, so IQ, of humans continue to drop. With an increase in the human population, we may only expect that in future those tendencies will not change unless we develop sustainable technologies to produce high quality foods. And it means high quality foods for humans. It is animal based fat, mostly saturated fat, but also the monounsaturated fat. So here we see how the size of the brain was changing, and last 3,000 years it is dropping sharply, and also what is happening IQ level drop steadily, and maybe in 50 years we will be much not much intelligent. So will we survive or not? Because we cannot keep technologies, complicated technology, and we cannot develop new technologies. So it is really very dangerous situation. As we know, herbivores use bacteria for fermentation to get the necessary nutrients from plants, and herbivores can be classified into different classes based on the structure of their digestive system. The main classification is based on where in the digestive tract microbial fermentation occurs, which determines how efficiently they can digest plant materials. The primary classes of herbivores are ruminants or foregut fermenters, the most efficient, the fermenters, they are the best in this sense to extract nutrients from plant-based materials such as cellulose and grass. So it is cattle, sheep, deer, and also hingat fermenters. This is a ferment and pseudoruminants and simple stomach herbivores. Foregut fermenters have a complex stomach with multiple compartments where microbial fermentation of plant material occurs before digestion. Hingat fermenters such as horses, rabbits, and some rodents have a simple stomach but an enlarged cecum and colon where microbial fermentation takes place. Pseudoruminants such as camel and llamas have a stomach structure similar to that of true ruminants but with simpler fermentation chamber. Hingat fermenters rely on bacterial fermentation to break down fibrous plant material into nutrients they can absorb and utilize. In hingat fermentation, bacteria in the gastrointestinal tract of herbivores, particularly in the cecum and colon, ferment cellulose and other complex carbohydrates present in plant material. Pardon. This fermentation process produces short-chain fatty acids. You see that again, how they get in fat, the cows and the other herbivores. Short-chain fatty acids are important to survive. They also use short-chain fatty acids as a source of energy, by the way. So as well as vitamins such as vitamins B, B12, and K2. So you can click on the source of information, read the article. The short-chain fatty acids produced through fermentation serve as a significant energy source for the herbivore, providing them with calories for metabolism. This is actually, they are similar to humans. They rely on fat, but it is on fatty acids, but fatty acids in this sense short-chain fatty acids, little bit different. So you see the difference between the foregut fermenters and hingat fermenters. Fermenters, this like horse, they have a huge size colon and huge size cecum. And then here it is also the cows, and they have very complicated structure of the fermented carbohydrate before the stomach, but also they have cecum and also they have colon, and so, but not as big as in horses, for example. So, okay, short-chain fatty acids can be also absorbed in the bloodstream and utilized by the animal body for various physiological processes. B vitamins produced through the fermentation play crucial roles in metabolism and other physiological functions. And medium-chain fatty acids and long-chain fatty acids, they are produced from short-chain fatty acids through various metabolic pathways. You can check it is again. What they are getting from these bacteria, they get mostly short-chain fatty acids, but they then inside the body of the cows and the ruminants, they are, and also other herbivores, they produce this middle-chain fatty acids, long-chain fatty acids, and also they get some amino acids from bacteria to produce protein. In the mammary glands of cows and other ruminants, some long-chain fatty acids, particularly 18, this really long, 18,0, may be desaturated to form corresponding monounsaturated acids. And milk fat contains approximately 400 different fatty acids, which make it most complex of all natural fats. Almost 70% of the fat in cow milk is saturated, and about 19% it is yet short-chain fatty acids, which are really very good for our health. So you see dairy fat composition, it is polyunsaturated fatty acids very little amount, monounsaturated fatty acids more, 25%, but mostly 70% in cow milk is saturated fatty acids, including short-chain fatty acids. Due to the specific of the digestive system of rodents and rabbits, they practice coprophagy to efficiently extract necessary nutrients from plants. Rabbits, hares, and pikas produce two types of fecal pellets, hard ones and soft ones called cecotropes. Animal in this species re-ingest their cecotropes, and cecotropes derive from shoot parts material that collects in the cecum and a chamber between the large and small intestine, containing large quantities of symbiotic bacteria that help with digestion of cellulose and also provide certain vitamins B. Cecotropes consist of plant fiber and short-chain fatty acids and up to 30% of microbial protein and amino acids. Vitamins also beneficial bacteria and fungi. To a lesser degree, coprophagy is also performed by piglets, wolves, dogs, and non-human primates. Also, little kids sometimes eat the feces. Okay, what is the difference? It is this cecotropes are small and they are soft and they are different from normal feces. Okay, again, difference between the stomach of these rabbits and human stomach. You see, big difference. They have this cecum very big, very big, where this fermentation goes, and so then this when these cecotropes are produced, the rabbits are just take them from anus. Humans don't have such capacity to produce cecotropes, but again, some fermentation goes in colon, but not much. And again, we are not adapted to use fermentation in our digestive system. Coprophagia is rare in humans and often associated with psychiatric disorders, dementia, religious cults, and sexual deviations. However, with modern technologies, coprophagy can be elevated to a common practice in the food industry. Yes, of course, just be prepared. If we will stop keeping cows and ruminants and we will produce not enough meat, then coprophagy can help us, especially to vegetarian and vegans. A fecal microbiota transplantation involves the consumption of feces. It is actually coprophagia already. It's like medical procedure. It is going and from a healthy individual by patients. Okay, so it is again it's already done. Okay, so this is how it works. So they take feces from some healthy donor, maybe young one, then they mix it with water and consume it with through the asshole or through and with always oral capsules. It is again up to the patients. Okay, whatever. Okay, this already involved. So we are coming to this. Okay, we are close to this to make it really common practice. A Japanese scientist Mitsuiki Ikeda from the University of Tokyo developed meat from human feces. Okay, great scientific achievement. Because he is seeking alternative protein sources. Okay, and they use bacteria and then use this bacteria or they grow bacteria on human feces, and then afterwards use bacteria to produce something which is they call meat, artificial meat or whatever. So researchers claim that they produced a meat substitute from feces as an alternative food source, aiming to reduce cost and the environment impact of animal meat production. Okay, this is our future, possible future. Okay, then certainly the fiber-rich human feces, especially from vegetarians, can be used to produce cultured meat and meat substitutes for vegans and vegetarians. I would never do it, but vegans and vegetarians, they are lacking many nutrients, especially vitamin B, vitamin B12. So they need it. So for them, it would be a solution if they want to stay on plant-based food, and then they use own feces to produce something, and actually they will go to this coprophagia. So this guy, you see that he is producing such shit burger pieces from shit to burgers. Okay, great achievement, congratulations. It is known that termites grow mushrooms which are edible with the use of own feces. The fungi form the symbiotic association with termites. Termites collect plant material, digest it, and then excrete feces containing wood particles and organic matter. The termite fungi thrive on this organic matter, and this symbiotic relationship between termites and fungi contributes to the ecosystem nutrient cycling process. Again, we need termites. Termites play a huge role in ecosystem in tropical countries, and then they grow mushrooms because again they cannot consume wood, they cannot consume plant material, but with help of fungi they can do it. Also some bacteria is involved, but okay, fungi, many termite species grow fungi. The termite mushrooms can be a potential source of nutrients and bioactive compounds with the health benefits for humans. Okay, yes, this is the way to go also. So instead of this using bacteria to produce this shit burger, you can use this mushrooms and mycelium and the fungi to produce something edible from feces. Mushrooms can be grown on a wide range of sterilized organic material, including human fecal matter. Yeah, why not? Human manure and poultry manure after composting and pasteurization are widely used to grow white button mushrooms. It's already, but okay, we are yet next step. We have to make next step to use human feces. But horse manure and poultry manure already in the play. In future, human feces and organic municipal waste can be used to grow edible mushrooms. Such a victory, such an achievement. Yeah, this is good. Okay, so this how the termites grow fungi. You see that they grow, they have some gardens underground, and they grow fungi, and then collect this fungi and eat, feed the larva, and then larva also, with help of larva, they also can eat this wood material. Okay, this is white button mushrooms, very common in Western countries. In tropical countries they don't grow, so but because it's very hot in here, but other species, other mushrooms grow. And personally, I was growing mushrooms in here. Oyster mushrooms grow quite well in Thailand. Human feces have been historically used as fertilizers in various Asian countries. Nowadays, due to concern about disease transmission and the use of human feces as fertilizers have been in part, not completely, replaced by synthetic fertilizers or other organic alternatives. Yet organic municipal waste and human feces can be used as fertilizers through composting, which involves the decomposition of organic materials in a controlled environment. The result in composting is rich in nutrients and beneficial microorganisms, making it excellent soil amendment for agriculture, gardening, and landscape. However, it is essential to ensure that any potential pathogens are eliminated and the final product is safe to use as fertilizer. So, North Korea using, they don't keep animals, they don't have ruminants, almost don't have, but they use own feces, and they make composting and use this as organic fertilizer. Yeah, smart move. Okay, we have to learn something from these North Korean people. So use feces, own human feces, to grow food. For now, the crop residues, such as straw, after sterilization, are mostly used as substrates to grow edible mushrooms. Crop residues, consisting mostly of cellulose, exceed grain mass with an average ratio about 1:66, not much, but yet okay. In the growing of maize and sugarcane, the mass of crop residues can be several times greater than the mass, dry matter. Several times greater than the mass of sugar and maize grain obtained. And I did it in Thailand. I was growing mushrooms. It's quite easy. I have personal experience of growing edible mushrooms such as oyster mushrooms, but I didn't use the straw. I used cocoa coir, which is again here as that it's available, and it is very good to use it. And I developed technology to not to sterilize the material, but yet just simplify technology, and it was really working fantastic. I was growing mushrooms, and more than 1 kilo per day. The yield was more than 1 kilo per day, and it's really easy. So, and coca coir is a fiber from the husk of ripe coconuts. One of the many advantages of growing mushrooms is that after harvested, the mycelium in the substrate is a protein-rich food additive for chickens. I also was keeping hens laying egg laying hens, and I was giving this substrate to them. They like it because it so has a lot of protein. So otherwise, the substrate can be reused, also with reduced yield, although with reduced yield of mushrooms. So how it go? You see, these mushrooms are grown on straw, and it is common, but also this coca coir can be used. It's again, you remove this outer shell and use it, cut to small pieces and use it to grow mushrooms. It works perfect again, and somehow again the mushrooms I was growing, they were so delicious. If I go to local grocery store and buy mushrooms, the same oyster mushrooms, not the same quality. So it is like okay, I was making it much better. So insects hold immense potential for producing enzymes and medications in the future, sure. Medications especially, and I use it, by the way. Insect feces are occasionally used in the production of certain beverages. So you can, insect feces, tea is considered as delicacy in China. Similarly, Indonesian civet coffee is made from insect feces also. In Chinese folk medicine, the medicinal use of dry feces from insects can be not only from insects, but yeah, just dry feces, can be dated back to approximately 1,700 years ago. These fecal medicines were commonly used to treat gastrointestinal, nervous system, skin, and gynecological diseases. Okay, you can read the article. The feces of sorted insects are used in folk medicine in extract form. For example, water extract. Yeah, okay. The insect feces have been historically employed in Brazil to treat digestive and skin disorders, and water extracts of worm poop. Yeah, it's very popular in India, for example, by the way. They contain powerful enzymes which can potentially improve the microbiota in the colon and digestion in humans. But nobody did research on it, so direct evidence is missing, lacking. So, but again, it is probably an interesting idea. Okay, but again, it's up to you, use it or not. So this is an example of this tea made from insect feces. And again, is this what is happening in the food market? So again, related to the feces and insect feces and other manure, also human feces especially. Yeah, well, it's our future probably. But personally, I believe that we can effectively reduce our environment impact by promoting sustainable and regenerative agriculture that improves soil health and biodiversity and, of course, fertility. For instance, a sustainable agriculture may involve keeping small farm crop animal systems that include pasture cows, goats, sheep, and chickens and ducks. Employing a rotational grazing system for cows and other ruminants allows pastures to regenerate, preventing overgrazing and soil degradation. Integrating diverse animal species into the farming system can contribute to pest control, nutrient cycling, soil fertility, and overall ecosystem health. Such crop animal farms minimize the chemical inputs like synthetic fertilizers and pesticides, provide environmental health and reduce reliance on external inputs. Providing forage-based diets for animals ensures sustainability by improving by utilizing natural resources efficiently. Okay, this I believe this can be future this way. So instead of using feces as food source, we can go to this sustainable agriculture and use cows, which are actually very good for environment. And and then cows, especially cows together with chicken, rotational use of these pastures is quite good. So I have personal experience in small scale sustainable farming. Yes, I loved it. I was doing it. Yeah, in particular, I was keeping egg laying hens, ducks, geese, and catfish. Hens I also was keeping for meat, and not only for eggs, but ducks and geese also for meat and for eggs. Catfish also have experience, and not to mention growing mushrooms. Mushrooms was quite important, interesting business for me. So also fruit trees and cash crops. I have 10 hectare farming land, or used to have. And so I was growing maize, rice, cassava, and yeah, it was quite. I like farming. I love nature. I also keep and operate till now and produce bacterial enzymes from bee products or from honeycomb produce. I use honeycombs, and then I produce some bee product, bee special enzymes. And this medicine works perfect, and it cures hypertension and atherosclerosis, which are big, actually main cause of death in the elderly. So for the production of enzymes, I use small reactors that mimic natural conditions. Yeah, maximum size of it was actually a few liters only, but I used many reactors, or used to have many reactors. And I was thinking I will make hundreds of such reactors, but again, it is little bit expensive, because if you have to manage and make hundreds reactors, it is some investment of money, sure. And now it is on pause. I interrupted it because of some regulations, and I cannot send my enzymes to Europe because of COVID regulations, and so now it is tough a little bit, but it's possible to increase production. So and the large volume reactors will not work. It just will not work, because you need air supply, you need nutrients to be mixed, and continuously. So small reactors work, large not. So my experience in chemical engineering, I make claims that industrial reactors cannot compete, but yet even small reactors, not to say industrial reactors of 1,000 liters volume, they cannot compete with living organisms in the production of food. Instead, we can use bee products and some insects to produce medical substances such as enzymes in small reactors, and with help of insects, because bee products are made with bees, with insects. So already now some worms can eat cellulose, or this is parts of sugarcane cellulose, and then they convert this cellulose into some bacteria and inside the stomach, and then also they can produce protein, fat, etc. So this is how it works. Again, small worm, they have very simple digestive system. So they eat some plant-based stuff. They have enzymes working inside, and they digest it, and some short-chain fatty acids and some proteins, amino acids maybe go to, and this is why worms are growing. But because of this stomach and because of this gut is very short, enzymes go out. So enzymes and also this what is produced. So we can use this feces from these insects, from these worms. And it's already the research business, actually. People sell water extracts from poop of some of worms, yeah, and it works. So okay, you can go not so many references I give, but again, very interesting subject, I believe, because again, I consider this, consider this business and this direction is very important, but my opinion, we better rely on this sustainable agriculture with of use of ruminants, because ruminants is the best biological reactor possible, and it is cheap, it is sustainable. The use of industrial reactors, it's so expensive, and again, it will never give you healthy food, never, to my opinion. But okay, but you see, more than $2 billion American dollars go invested in this direction, while people, to my opinion, better to invest money to production of this food with insects, and also with small bioreactors. It is better, and growing mushrooms also sustainable and good, and okay, whatever. So I hope you got some interesting information, and again, I don't have any support, official support. I do it on my own funds. So if you want to support, at least press like and bell button, subscribe to my channel, share this video with your friends and family. Again, I express this my opinion. I'm not medical professional. I cannot compete with this government and WHO and all this agenda to promote vegetarian food, and to stop breeding cows, and to stop production of meat what we have before, and to move people to plant-based diet. Okay, to my opinion, if you want to live long, no way, no way. You have to you have to understand that our digestive system is not adapted. We just cannot survive on plant-based food, just cannot. So we have to use animals. With animals are adapted to this, and we have to use at least dairy products or eggs, and this is with no cruelty and easy, and it's fun. Growing mushrooms even more easy, and so why not to do it? Why not to do it? Why to limit, and why to destroy traditional way of production of meat? Okay, have a wonderful day. Ciao, ciao. Thank you for your time.